So Exocube 2 holds a mass spectrometer, which is a special device that's meant to measure the density of very small particles. So ions, atoms, that kind of stuff. And we're trying to measure that in the high atmosphere. And we're nearing the end of Exocube's lifetime. Launch is slated for later this year. We can't talk about the date specifically. But we're in final stages. We're assembling, we're debugging, we're getting our final functionality checks and environmental checks ready to go. So Exocube is a fun mission because we don't actually have much data of the exosphere, which is the part of the atmosphere that Exocube is analyzing. That's kind of where the name comes from. And we've had data in the past because the payload has been used before, but it's really not current. And so we think of Exocube as kind of a glorified weather satellite. And the weather data we have is very old. So it's kind of exciting to be part of something that's like, we're re-updating our catalog, we're kind of understanding what's going on right now in the exosphere. I've been the mission lead for a year now, and it's pretty surreal having it come to kind of a close. It's looking more and more likely that it'll launch before I graduate, which is pretty exciting. And just in general, it's exciting to have something that you've been working on for almost a whole year of my life finally kind of come to fruition and finish up its life on Earth and hopefully make it to outer space.
So in Exocube, actually a lot of the stuff I've been doing has been more focused on electrical troubleshooting, and so we kind of take things as they come. So whatever problems kind of come up with our electrical boards, we kind of try and figure out what's wrong, kind of pinpoint where it's at, and then try and find solutions kind of on the fly to fix those and kind of do the modifications that will fix them in order for the boards to work. For the satellite to function, it needs power, and then for the payload to work, and kind of for mission success of the entire satellite, whatever the science payload is, whatever kind of experiment it's running, it needs to be able to collect data and then send that data back down to the ground once it's been collected. And so kind of electrical engineers on these projects get to design and develop boards that kind of control all this and will store data and kind of regulate power for the entire satellite.
I worked a lot on the assembly procedures and then actually assembling it. So I've worked a lot on building the ETU and making sure that all the systems fit together correctly. So that goes from the stack to how the payload interfaces with the bus. And I've tried to iron out as many flaws as I can with the help of my fellow mechanical teammates, but it's definitely a long process, and I've enjoyed it every step of the way. I think this is probably the coolest thing I've ever done in my life, being a part of this lab. And it's just so weird to me to think that I'm taking things that I'm learning from the classroom, applying it here, and then this thing that we're building as a lab is going to go into space and be orbiting Earth and doing an actual experiment. And that's just super cool to me.
Exocube right now is kind of in the later stages of its life cycle, and so I've been working personally on a lot of assembly and integration. And for our small spacecraft, before we work on the final flight unit, we work on our engineering test unit. So for me, I've been working kind of with the mission lead, Aaron, and then also with Lucas, another mechanical engineering student, developing assembly procedures on our test unit so that we're ready for flight when we're working with our actual payloads. So it's been a good experience for me because it's exciting when you actually get to go and work on flight payloads and cool science missions, but it's kind of scary because you have to be really prepared for that. And you have to make sure that you're working together as a team and all the technicians know what's going to happen beforehand. So that's been a really cool experience. I've had other internships at big companies, and my managers have always been senior engineers that have worked on projects for decades. But it's really cool. For PolySat, our mission lead is just another student, just like me. And so it's great to be in an environment where students get so much responsibility over the work that they're doing. And it's something that's really unique, I think, about PolySat is all the mission leads are students, all the technicians are students, all the designers are students. And it's something that gives people kind of a great leap forward before they go on and work on their senior project or internships out in the real world.
Feel like a real EE now?
I feel like a real boy now.
Like Pinocchio, except with electronics.